My name is Cassandra Morrison. Everyone calls me Cassie. I'm 37 years old, and I'm an astrophysicist. I fell in love with space when I was 8 years old. I grew up in Boulder, Colorado. My dad, Tom Morrison, was an electrical engineer. My mom, Ruth, taught high school mathematics. We lived in a modest house with a big backyard and clear mountain skies. One summer night, my dad set up a telescope in the backyard. It wasn't fancy, a beginner's model he'd bought at a garage sale, but to me it was magic. "Come look, Cassie," he said. I climbed onto the step stool and looked through the eyepiece. At first I saw nothing, just darkness. Then my dad adjusted the focus, and suddenly, there it was, Saturn. I could see the rings. Actual rings around an actual planet millions of miles away. I gasped, "Dad, is that real?" He laughed. "It's real. That's Saturn. One of billions of objects in our solar system. And our solar system is just one of billions in the universe. What else is out there? Everything. Stars, planets, galaxies. Maybe even life on other worlds." I looked up from the telescope. "How do we find out?" "People like you study it. Scientists, astronomers. They ask questions and find answers." That night, I decided, I would be one of those people. I would find answers. Through middle school and high school, I excelled in math and science. I wasn't naturally gifted. I had to work hard, but I loved it. Every equation, every formula, every concept felt like unlocking secrets of the universe. My physics teacher, Mr. Chen, encouraged me. "Cassie, you have real potential. Have you thought about studying astrophysics?" I had thought about nothing else. Senior year, I applied to colleges. I got into several good schools with full scholarships. I chose one with a strong physics program and headed off at 18, ready to pursue my dream. College was harder than I expected. The physics classes were brutal: quantum mechanics, thermodynamics, mathematical methods. I studied constantly. My grades were good, but I had to fight for every A by junior year. I was ready for my first astrophysics class. This was it. This was what I'd been working toward. The class was taught by Dr. Harold Brennan. He was a legend in the department. Published over 100 papers, worked on major space missions. Everyone wanted to take his class. There were 30 students. Only 4 were women. The first day of class, Professor Brennan walked in and surveyed the room. "Astrophysics is not an easy field," he began. "If you don't have strong mathematical aptitude, you should leave now. This class will break you." No one left. We were all determined. The first few weeks were intense. Complex equations, orbital mechanics, stellar evolution. The material was challenging, but I was managing. I got an A on the first quiz, an A- on the second, but I struggled with one particular concept: differential equations applied to planetary motion. I understood the theory but couldn't quite visualize the application. So I went to office hours. Professor Brennan barely looked at me. "If you can't grasp this now, maybe this field isn't for you," he said dismissively. I went home and studied harder. I worked through every practice problem. I asked other students for help. By the midterm, I had it figured out. I got an A on the exam, one of the highest scores. But then came November, the day that changed everything. We were discussing differential equations again, a more advanced application. I had a question. The solution in the textbook didn't match my calculation. I raised my hand. "Professor Brennan, I'm getting a different answer on problem 7. Can you walk through the steps?" He stopped writing on the board. He turned slowly. He looked at me with something like annoyance. "Miss Morrison, this is basic mathematics. If you can't follow this, perhaps astrophysics isn't the right field for you." I felt my face flush. "I just need clarification on—" He interrupted. "Let me say something. And this is fact, not opinion. Most women don't have the mathematical mind required for space science. It's evolutionary psychology. Men evolved better spatial reasoning for hunting. Women evolved different skills. It's not your fault. It's biology." The classroom went silent. 30 students staring. 4 women frozen. "My advice?" He continued. "Consider switching to biology. Or chemistry. Something more suited to your natural abilities." I couldn't speak. I couldn't move. I'd just been told in front of my entire class that my brain wasn't built for my dream. Class ended. I grabbed my bag and rushed out. I made it to the bathroom before the tears came. My friend Rachel, An engineering major found me 20 minutes later. "Cassie, what happened?" I told her everything. She was furious. "He can't say that. That's discrimination." "But what if he's right?" I whispered. "What if I really can't do this?" Rachel grabbed my shoulders. "Look at me. You got an A on the midterm. You're one of the top students. He's wrong. He's a sexist dinosaur, and he's wrong." That night, I looked at all my grades, quiz scores, exam results, problem sets. I was consistently in the top 10% of the class. The data didn't lie. I could do this. I made a decision. I wouldn't drop the class. I wouldn't switch majors. I would prove him wrong. For the rest of junior year and all of senior year, I took every class Professor Brennan taught. Advanced astrophysics, cosmology, stellar physics. Every assignment, I aimed for perfection. Every exam, I studied until I could solve problems in my sleep. I got A+ in every single class. Brennan never acknowledged it. Never praised me. Never admitted I was excelling. He just kept teaching as if I didn't exist. Senior year, it was time to apply to graduate schools, PhD programs in astrophysics. I applied to 8 schools: Harvard, MIT, Caltech, the top programs in the country. I needed recommendation letters. Brennan was the department chair. The most established professor, his letter would carry weight. I knocked on his office door. "Professor Brennan, I'm applying to PhD programs. Would you write me a recommendation letter?" He leaned back in his chair. "I don't think graduate school is the right path for you, Miss Morrison. I have a 3.9 GPA in astrophysics. GPA isn't everything. Research requires a different kind of thinking. I've published 2 undergraduate research papers." He sighed. "Fine, I'll write something. But don't expect miracles. I applied to 8 programs. I got into 2. Both were good schools, but not top tier. I got rejected from MIT, Harvard, Caltech, and 3 others. Later, I found out why. A friend in the admissions office showed me Brennan's letter. It said I was an adequate student who was hardworking but not exceptional. Adequate. After 4 years of perfect grades in his classes, I was 25 years old when I started my PhD at a second-tier university. It was a good program, but it wasn't my dream school. And I knew why. PhD programs are brutal for everyone. Long hours, low pay, constant pressure to publish, imposter syndrome. For me, it was all of that, plus a burning need to prove something. My advisor was Dr. Maya Patel, one of the few women in astrophysics at that level. She was brilliant and supportive. "I heard about Brennan," she told me during our first meeting. "He's old school. Ignore him. Focus on your research." My research focused on exoplanets, planets outside our solar system. Thousands had been discovered, but most were gas giants or scorched rocks too close to their stars. I wanted to find something else, something rare, Earth-like planets, rocky worlds in the habitable zone, places where liquid water could exist, where life might be possible. It was a long shot. Earth-sized planets are hard to detect. Their signals are weak. Their effects on their stars are tiny. Most researchers focused on easier targets. But I was stubborn. My thesis took 5 years. I developed new detection methods, combined multiple data sources for higher precision. I published 3 first author papers. They weren't groundbreaking, but they were solid. At 30, I defended my dissertation. The committee was impressed. I passed with distinction. Dr. Cassandra Morrison. Finally. But the job market was terrible. Postdoctoral positions were competitive. I applied to 20. Got 3 offers. I accepted a position in Europe, a major observatory, access to some of the best telescopes in the world, a team working on exoplanet detection. I packed my life into 2 suitcases and moved across an ocean. The European Observatory was incredible. Massive telescopes, cutting-edge equipment, brilliant colleagues from around the world. I spent 3 years there, working 16-hour days, analyzing data from multiple telescopes. Looking for that needle in a cosmic haystack, we detected dozens of exoplanets during my time there, but most were hot Jupiters. Massive gas planets orbiting close to their stars. Interesting scientifically, but not habitable. I kept searching for Earth-like worlds. Small, rocky, in the habitable zone. The Goldilocks region where temperatures allow liquid water. During my second year, I developed a new technique. Multispectral analysis combining optical, infrared, and radio data. It was more sensitive than traditional methods. I published the paper at age 33. Novel multispectral approach to Earth analog detection. The paper got attention. Other researchers started using the method. It worked, but I still hadn't found what I was looking for. That potentially habitable planet. That sign that we might not be alone in the universe. Then I got a job offer. Back in the United States, a major research institute. They wanted me to lead my own team. Full funding. Guaranteed telescope time. I was 33 years old and I was coming home. Leading a research team was different from being a postdoc. Now I was responsible for other people's careers, for getting results, for securing funding. I hired carefully. Dr. James Wu, a data scientist who specialized in machine learning for signal detection. Dr. Elena Rodriguez, an expert in spectroscopy and atmospheric analysis. 2 postdocs, 3 graduate students. We had one mission: find habitable exoplanets. The first 2 years were frustrating. We had several promising candidates, planets that seemed right, but when we did follow-up observations, they turned out to be false positives. Noise in the data, artifacts from the instruments. By year 3, my funding renewal was coming up. We needed results, real discoveries, something to justify the investment. The team was discouraged. Maybe the method didn't work as well as we thought. Maybe habitable planets were rarer than we hoped. I called a team meeting. I know it's been hard, I said, but we're close. I can feel it. 1 more year. Let's give it 1 more year, they agreed. We kept working. It was 2 a.m. on a Tuesday in March. I was alone in the lab, reviewing data flagged by James's machine learning algorithm. Then I saw it. A signal, faint but consistent, a periodic dimming of starlight, the telltale sign of a planet passing in front of its star. I pulled up the details. The star was a K-type, slightly cooler and smaller than our sun, but stable and long-lived. Perfect for life. The planet's orbital period was 387 days. Earth's is 365. Close. Size estimate, 1.2 Earth masses. Rocky, probably. Not a gas giant. And the distance from its star? I did the calculation 3 times to be sure. Habitable zone. Right in the middle of it. My hands were shaking. This could be it. This could actually be it. But I'd been disappointed before. We needed to verify. Multiple observations. Different telescopes. Independent confirmation, I called the team. At 2 a.m. No one complained. I think we found something, I said. Something big. The next 6 months were intense. We used every telescope we could access. Optical, infrared, radio. We collected data from multiple angles, multiple wavelengths. James ran the analysis. Signal is consistent across all datasets. Not an artifact. This is real. Elena analyzed the light spectrum. I'm seeing absorption lines that could indicate water vapor in the atmosphere. Could. We need more data to be certain. More observations. More analysis. We brought in independent teams to verify our work. We couldn't afford to be wrong. By September, we were certain. We had discovered a potentially habitable exoplanet. Earth-like in size. Rocky composition probable. Orbiting in the habitable zone of a stable star. Possible water vapor in the atmosphere. It was everything I'd spent 16 years searching for. I sat in the empty lab at midnight and cried. Not from sadness. From joy, from relief, from the overwhelming realization that I'd actually done it. Before we could announce the discovery, we had to write the paper. Scientific discoveries aren't real until they're peer-reviewed and published. I wrote it over 3 weeks, every word carefully chosen, every data point verified. James and Elena contributed their sections. The entire team was listed as authors, with me as principal investigator and first author. We submitted to one of the top astrophysics journals. Then we waited. Peer review took 4 months. 4 months of anxiety. What if the reviewers found a flaw? What if we'd missed something? The response came back in January. Accepted. The reviewers were impressed. They called it one of the most significant exoplanet discoveries in recent years. The journal wanted to feature it as a cover story. We scheduled a press conference. Word got out. International media wanted to cover it. This wasn't just a scientific discovery. This was, are we alone in the universe? Territory. The press conference was held in a large auditorium. Hundreds of journalists, cameras everywhere. I'd never experienced anything like it. I stood at the podium. James and Elena sat beside me. My team filled the front row. I explained the discovery, showed the data, described the planet's characteristics, its potential for harboring life. A reporter raised his hand. Dr. Morrison, what does this discovery mean? It means, I said carefully, that Earth-like planets in habitable zones are out there. We've suspected it, but now we have strong evidence. This planet has the right conditions. The right size, the right distance from its star, possible water. We can't say definitively that life exists there, but if we were going to find life elsewhere, this is exactly the kind of planet we'd look for. Another reporter. How did you find it when so many others couldn't? We developed a new detection method. Multispectral analysis combining data from multiple sources. It took years to perfect. An incredible team, and honestly, some luck. But mostly it took persistence. Not giving up when other candidates didn't pan out. The questions continued for an hour. When it was over, I was exhausted but exhilarated. The story went global. Headlines everywhere. New Earth? Most promising planet for life. Historic discovery. I was 36 years old, and I was suddenly famous in the scientific world. The paper was published 3 weeks after the press conference. Discovery of a potentially habitable, Earth-analog exoplanet in the habitable zone of K-type star, HG 4307. First, author, Dr. Cassandra L. Morrison. The response from the scientific community was overwhelming. Congratulations from colleagues, interview requests, invitations to speak at conferences. And then, 1 week after publication, I received an email from Dr. Harold Brennan, subject, congratulations and collaboration request. I stared at the name for a full minute before opening it. Dr. Morrison, congratulations on your exoplanet discovery. Truly remarkable work. I always knew you had potential, even back in your undergraduate days. I've been reviewing your paper and methodology with great interest. The multispectral approach is innovative. As it happens, I've been working on related research examining K-type star systems and their potential for hosting habitable planets. I believe there's significant overlap between our work. I'd like to propose adding my contribution to your research, perhaps as a co-author on a follow-up paper, or even a revised version of the current publication. My decades of work on stellar classification provided foundational knowledge that your detection method builds upon. I think acknowledging that connection would strengthen the paper's impact and give proper credit to the broader research community. Let me know your thoughts. I'm confident we can work something mutually beneficial out. Best regards, Dr. Harold Brennan, Professor of Astrophysics. I read it 3 times. 16 years ago, he told me I didn't have the right mind for space science, that I should switch to biology, that women were biologically incapable of this work. Now he wanted his name on my discovery. I called Maya Patel. She was a full professor now at another university. He wants to be added as a co-author, I said. Of course he does, Maya replied. Men like him always do. What are you going to do? What should I do? What does your gut say? My gut said no. Absolutely not. I wrote my response that night. Dr. Brennan, thank you for your email. However, I must decline your request. Co-authorship requires substantial intellectual contribution to the specific research project. While your past work on stellar classification is part of the general foundation that all researchers in this field build upon, it does not constitute direct contribution to this discovery. This discovery was the result of 16 years of research, including 5 years of my PhD, 3 years as a postdoc, and 5 years leading my own team. All of that work began after my undergraduate education at your institution. I'm certain you remember your astrophysics class in November of my junior year. You told me, and the entire class, that women don't have the mathematical mind for space science, that we should consider other fields more suited to our natural abilities. You advised me against pursuing this path. You wrote a lukewarm recommendation letter that kept me out of top PhD programs. You told me I was adequate. Not exceptional. You were wrong. Not just about me, but about your entire approach to evaluating potential in students. I will not be adding you to this paper. The authors listed earned their place through years of dedicated work on this specific project. I wish you well in your research. Dr. Cassandra Morrison, Principal Investigator. I sent it. 2 days later, he responded. The tone was different, angry, defensive. He claimed I wouldn't have the skills to do this research without his teaching. That I was being ungrateful and unprofessional. that refusing to acknowledge his foundational contributions was unethical. I forwarded the entire email chain to the University Ethics Board. Attempted inappropriate claim to co-authorship credit. Harassment of former student. The Ethics Board took it seriously. They investigated. Other former students came forward, women who Brennan had discouraged, whose recommendation letters had been deliberately weak, who'd been told they weren't smart enough. The investigation took 3 months. The outcome, formal reprimand. Brennan's teaching duties were reduced. He was removed from the graduate admissions committee. His reputation took a significant hit. He retired a year later. I felt nothing when I heard. Not satisfaction, not anger, just closure. He didn't matter anymore. My discovery is now in textbooks. Informally, some people call it Morrison's Planet. Formally, it has a catalog designation. I've received awards. Major ones. Recognition from the scientific community. Speaking invitations at the top universities in the world. MIT invited me to give a lecture. I accepted. But the most meaningful moment came at a conference for young women in STEM. I gave a talk to 500 early career scientists. Most were in their 20s. All were women or non-binary individuals. All had chosen difficult scientific paths. When I was 21, I told them, a professor told me I didn't have the right mind for space science, that women were biologically incapable of advanced astrophysics. For a long time, I wondered if he was right. But here's what I learned. There's no such thing as a mathematical mind that only some people have. There's mathematical training, there's persistence, there's curiosity, and none of those qualities are limited by gender. This discovery wasn't just mine. It belongs to my entire team, Dr. James Wu, Dr. Elena Rodriguez, all our postdocs and students. But I led that team. I made decisions. I pushed forward when things got hard. And if I can do that, so can you. When someone tells you that you don't belong, don't believe them. Work. Prove them wrong with data. And most importantly, when you succeed, hold the door open for those coming after you. The applause lasted 5 minutes. After my talk, a line of young women waited to speak with me. Many were crying. Many told stories similar to mine. Professors who doubted them. Advisors who discouraged them. People who said they weren't smart enough. You showed us it's possible. One young woman said, "Thank you." That's when I realized the discovery was important. But the impact on these young scientists might matter even more. I'm 37 years old now. Still searching. Still discovering. We've found 3 more potentially habitable exoplanets using the method we developed. None as promising as the first, but each adding to our understanding. Next-generation telescopes are being built. More powerful instruments, better resolution. Within 10 years, we might be able to analyze exoplanet atmospheres in detail. Look for biosignatures, signs of life. Maybe we'll find proof. Maybe we won't, but we're asking the right questions, and that matters. Last week, a new graduate student joined my team. Her name is Maya Chen. She's brilliant, sharp, asking excellent questions. "Dr. Morrison," she said after her first week, "I wanted to thank you. I almost quit astrophysics during my undergrad. My professor told me women don't belong in hard sciences. But then I read about your discovery, about everything you overcame to get here. That's why I applied to work with you," I smiled. "Welcome to the team, Maya. Let's find some planets." As she left my office, I thought about that night when I was 8 years old. Looking through a telescope at Saturn, asking my dad what was out there. Now I know some of the answers, and I'm helping train the next generation who will find even more. Professor Brennan was wrong about me. But more than that, he was wrong about what matters in science. It's not about who you are. It's about what you're willing to work for. The universe doesn't care about gender. It only cares about questions. And I'll keep asking them for as long as I can. Because somewhere out there, on a rocky planet orbiting a distant star, there might be someone looking up at their sky, wondering if they're alone. And thanks to my team, we're a little bit closer to answering that question. That's enough for me.